Okay, so we've worked on mastering our first equation that we have seen with our energy unit in 15.1. That was calculating kinetic energy. That's energy of motion, and the two variables that decide that is how much mass something has and its velocity, because again, kinetic energy is a measure of motion energy. So we can also calculate another form of energy, which is potential energy. There's kind of three different types of potential energy, and I'm going to show you today how to calculate just one of them, and that's gravitational. So potential energy is stored, and there's two ways that you can store energy. One is a result of position. So how much energy a book has sitting on the second shelf from the floor versus the fifth shelf from the floor. Or a person that's going to dive off the low diving board versus how much somebody has that is all the way on the high diving board. Shape, that means something that's wound up like a wind-up toy that has a spring or coil. If you have a rubber band stretched back, that has potential energy due to shape. So the main two types this textbook covers is gravitational potential energy, and like I said, that's what we're mainly going to be calculating, and then elastic potential energy as well. So gravitational potential energy depends on the object's height. So that type of energy is raised or increased when an object moves from a lower to higher level. So for example, as you climbed up to the third floor of Q, you had increasingly more potential energy, stored energy, if you were to stop on the second floor versus the third floor. So the third floor would give you more gravitational potential energy than you would have on the second floor or even the first floor. And so a variable that's also consistent between the two is mass. So let's say you were going from all the way at the bottom of Q all the way up to the top floor. Let's say in one scenario you have your backpack, and another you don't. So your mass increases as you have that backpack strapped onto your back. And so you give yourself more gravitational potential energy two ways. One, by having more mass because of that backpack. The second is by climbing to, say, from the second floor to the third floor. And then we have a variable that's coming back that we saw last chapter, and that's acceleration due to gravity. So depending on how much the g-force is on that particular planet, for example, we're going to mainly focus here on Earth, that's also a factor that decides how much gravitational potential energy something may possess. So this chapter again only has two equations, and so we have a formula for gravitational potential energy. So I'm just going to go ahead and break it down into its variables. So gravitational potential energy, just like kinetic energy is Ke, we can say that we have GPE. It's based on three variables: the mass of the object, its height relative to the ground, and then the acceleration due to gravity. So we have m times g times h. So mass, like we've seen, we want that in the unit of kilogram. Height, we want as a meter. And so acceleration due to gravity is meters per second squared. So based on the layout between the equation that we used for kinetic energy and how those units work out with that formula, same thing here with the potential energy equation based on how these work out with multiplication, we still are going to measure this in the joule, which is an uppercase J. So again, all units that we've seen before, again, the combination from these give us the same final unit for energy. And again, all the options for that is attached to that equation handout. As I mentioned a little bit, the other kind of elastic potential energy that's out there is elastic. So, for example, if you've ever shot archery, as you draw your bow back, that is storing energy. As soon as you let go of that, we have a transformation take place, and that's where an arrow is then sent forward. If you, again, like those wind-up toys we used in the Zoom How Fast is Fast lab, same thing. We have a spring in there, that coil. As you wind that up, that gives it stored energy. As soon as you let go of it, it then turns into kinetic energy. So we're going to kind of just dive into our first example. And we have this diver that's climbing a platform, and this individual has a mass of 50 kilograms. What is the potential energy? And I know it didn't say specifically, but as soon as it mentions height, we know that we're talking about GPE. So what we know in this problem to start is the mass and height. So 10 meters tells me height. The kilograms tells me mass. And it wants to know what is the GPE. Well, when you take a look at the formula, we have that GPE is equal to mgh. So we're missing a variable, and that is g. If you recall, acceleration due to gravity on Earth is a constant. That constant is 9.8 meters per second squared, and that's on your formula sheet for you. So now it's pretty straightforward. We can plug in. So my mass is 50 kilograms, my height is 10 meters, and my acceleration due to gravity is 9.8 meters per second squared. 2 decimal places, if we get them, and this one we don't particularly get a decimal place, we get an answer of 4,900. We're solving for energy, so the unit here is going to be the joule. And so we've calculated the GPE for this individual. In our next example, we're going to change things up. It says, what is the distance, or what distance is a book from the floor if the book contains 196 joules, and that should say of energy, and has a mass of 5 kilograms. So as we start taking a look at the information, what we know is that it has this joules. And so I know that is telling me how much energy it has based on that unit. And I know that the mass is 5 kilograms. It says here, what is the distance? That means I'm finding the height. So that means the last thing I need is what my acceleration due to gravity is. We can safely assume we're here on Earth, so we're going to use that 9.8. Our formula. Okay, so if you go to your formula sheet, you're going to see that height is equal to GPE over your mass times G. So now we can start the plug-in step. My GPE is 196 joules divided by my mass of 5 kilograms times my acceleration due to gravity of 9.8. So before you just start typing this into your calculator, you need to be very careful because order of operations here can be your best friend or not so much. So when you type this in, you have to remember that if you type this in all at once, it's not going to simplify it out correctly. So my recommendation of what you need to do to solve is simplify. Like we did with the kinetic energy, break it down. So to simplify, we need to break down the bottom part by taking 5 times 9.8. So when we do that, we get 196 divided by 49. Then you want to divide it out, and when you do that, you then get an answer for meters. If you do not type it in, if you type it in all at once, it doesn't understand that 9.8 is in the denominator, the bottom. If you type it in all at once without using parentheses, it thinks that 9.8 is in the top with the 196. So that's where simplifying it, then doing the division step, becomes really helpful. Down to our last example then, with this car. It tells us that it's sitting on a hill which is 20 meters higher than the ground level. So I can already see that based on what I'm given, I know the position, the height is 20 meters. It says find the mass of the car, so I know M is what we need to find. It tells me that the GPE is 362,000 joules. And again, the last piece that's not always flat out given is the acceleration due to gravity, that constant of 9.8. So again, much like our formula for solving for height, we get a formula for mass that GPE is our height times our acceleration due to gravity. So we can go ahead and plug in. We have 362,000 4,000 joules in this automobile divided by our 20 meters times our acceleration due to gravity. So again, when we have an equation like this and we have them separated, we need to keep track of order of operations. So simplify what you can. So you can simplify the denominator by taking 20 times 9.8. When you do that, you get 196. Once you simplify it, you can then divide. So you can take 362,000 divided by 196. When you solve this one, we do get a decimal. You can get 1,846.94, and we're finding mass, if you look at your formula sheet, kilograms. Reach out to me if you have any questions.